We're going to look at exponential patterns and graphs. This is the basic equation for the exponential graph. So y equals some number r to the power of x. Now this a here is a constant. In other words, it could be a number, and r is a common multiplier. What do we mean by a common multiplier? Well, if you look here at the tables that we've got for 2 to the power of x, you notice that if you look at the y's, then if the connection between them is you're multiplying by 2, you can see that here. So 1 times 2 is 2, and if you multiply 2 again, you'll get 4, and you multiply 4 by 2, you'll get 8 and 16. There's an example where the numbers go down. Okay, so if you have 1 multiplied by a half, so you're halving the numbers. This time it's like dividing by 2, but halving. Okay, so it's a half, a quarter, an eighth, a 16th. So even if you had a number that was like 100, say you had 100 up here, and you halved it and it was 50, and then it would be 25, 12.5, etc. Okay, it's still halving. Okay, so if it's multiplying by 2, so look at the one on the left here. If you're multiplying by 2, and then it'll be 2 with x in the power. That's why it's called an exponential function or exponential graph or an exponential table pattern. Okay, this one here, the common multiplier is actually a half, so we have a half to the power of x. Sometimes you have numbers written in front, so it could be something like, if you're taking the one on the left, it could be 3 times by 2 to the power of x. Now, there's none here at the moment, so we're just going to have a look at what we have here. So let's go back to the original equation. Okay, so you'll have a r to the power of x. The ones below are really 2 to the power of x, where r is 2 in the power of x, and here r is a half. Now, the graphs generally look like this. They're not parabolas and they're not straight lines. Okay, so this is the third type of function that you get. It's called an exponential, and it will be like a growth curve. This line is following very closely to the x-axis, not touching it, and then it suddenly grows. It's called an exponential curve. The opposite is what you call a decay curve. Sometimes you see them in science, and the number gets smaller and smaller and smaller, and it gets smaller and smaller and smaller until it gets very small, but it actually doesn't ever become zero. So these graphs here both have a line at the bottom, which is called an asymptote. We'll talk about that at some other stage. Okay, so if you had a pattern like this, this one here, you could make a table up just by putting values of x, which is 0, and if you put it into here, it's 2 to the power of 0, which gives you 1. If you make x 1, put 1 in here, okay, then it'd be 2 to the power of 1, which is 2. If you have x is 2, then it would be 2 to the power of 2, which is 4, and 2 to the power of 3 is 8, 2 to the power of 4 is 16. And it could be the opposite if you have halves. Okay, so this is just making up a table. If you put them onto a graph, if you just plotted them, you'll get these things here. Okay, and then you do a smooth curve through them. Okay, we're going to stop for a minute while you have a think about that.